Greetings, I'm Squared here, and today we're going to talk about solving systems of linear equations using substitution. So there's lots of things that you get substituted. These days you can substitute, especially in sports, one person comes in, one person goes out kind of thing. In basketball, you can't have 6 people on the court, so you know what substitution is. One thing comes in while the other thing goes out. So in math, when we substitute things, we have to substitute things that are equal. So you can't substitute a 4 for a 5 and expect to get the same answer, because that doesn't work. So these are the rules, or the steps for substitution. We're going to get one variable alone in one equation, then we're going to substitute whatever that expression that we got alone in for the variable that it equals, and then we'll get a new equation. We solve it, we substitute. So this one's already nice and pretty set up for us. Y is already alone, so I don't actually have to get y alone. And so what I'm going to have to do is I'm going to have to say 2 times y equals x minus 8. Now notice, this is the second equation. I didn't put a y in because I'm going to take that y out and I'm going to substitute what y equals. If y equals 2x minus 10, then anywhere I see a y I can put 2x minus 10. So I'm going to put 2x minus 10 instead of y. The reason I do this is because I can't solve an equation with 2 variables unless I have 2 equations, because then I can substitute it in. So before, I couldn't tell you what x and y equaled. I can't tell you what these two intersect unless I find x and the y, and it would literally take you days if you were just trying to guess numbers. So this is what we do. We substitute. So I took this equation, I took the y out, and I substituted what y equals. And then I'm going to try to get my math together. So 2 times 2x is 4x. 2 times negative 10 is negative 20. And it equals x minus 8. Now I need to get x. It says solve the new equation. This is my new equation. I'm going to solve it. So I'm going to subtract x on both sides. I get 3x. I'm going to add 20 to both sides. And I'm going to get 12. 20 minus 8 is 12. I'm going to divide both sides by 3, and now I know what my x is. My x is 4. So up here, this is where my answer is going to be. Now that I know x equals 4, I know that I actually have one solution, because remember, there's 3 things that can happen. I can get one answer, 1 point. I can get an infinite number of points if it's the exact same line, or I can get no solution if the lines are parallel. My goal is to find out where these 2 lines meet. So now I've got to find my y. So I take my x that I just got, right, and I plug it back in to the x over there. So I'm going to get y equals 2 times x minus 10. What am I going to put in for my x? My 4. So I get 8 minus 10. That gets me a negative 2. And I can check it in this equation just to make sure. So what's 2 times negative 2? Because that's 2 times y, and our y is negative 2. That's negative 4. There's my check. And then does 4 minus 8 equal negative 4? Yeah, it does. So I know I'm right. So my point of intersection between these 2 lines is 4, negative 2. All right, on to this one. So we have y all by itself again. So I'm going to take 2x plus 3y, 3y equals negative 7, and instead of y, what am I going to do? Put what y equals. So 2x minus 1. So 2x plus 6x minus 3 equals negative 7. So it's, again, you're distributing 3x. 3 times 2x is 6x. 3 times negative 1 is negative 3. And now I solve that new equation. So I get 8x minus 3 equals 7. If I add 3 to both sides, I get 8x equals 7, 8, 9, 10. So x equals, a fraction. Now that is interesting, because normally if I get something like that, I think, I made a mistake. Oh, I see my mistake. Did you catch my mistake? This is such a common mistake. Do you see that negative sign right there? That should have been a negative. And if that's a negative, then when I do this, I get a negative 4. Negative 7 plus 3 is negative 4. And then I don't get a 10/8, which is kind of weird. Well, not that 1/2 is any better, but it is a little bit better. So I'm going to get a negative 1/2 for my x. So now let me plug it back in for y and see what I get for y. So I'm going to make a line here so you can see that I'm doing something different over here. Y equals 2 times x minus 1. I'm going to put what I just got for x in and see what I get out for y. So half 1/2 times, negative 1/2 times 2 is negative 1, and a negative 1 minus 1 would get me a negative 2. So I think this is my answer, but to double check for sure, I'm going to plug it in right here. So this is my check over here. I'm going to say 2 times x plus 3 times y. And if I get a negative 7 when I plug negative 1/2 in for x and negative 2 for y, I know I'm good. So that's a negative 1 minus 6. And yes, that's negative 7. So I know I am right. That's my answer. All right, let's try another one. You'll notice in this one that x and y are not alone, neither one of them. So that's our first step when we solve by substitution, is to get a variable alone. So I'm going to take this variable, this top equation, and I'm going to add y to both sides. And when I do that, I get x equals 6 plus y. And then that's what I'm going to substitute in for this x, because it says x equals 6 plus y. So I'm going to say 6 plus y. That's my x, remember. Then what plus y equals 10. So these are the same, and I'm just substituting that. So there's this parenthesis is just because that's what x equaled over here. You don't really need them because there's nothing being multiplied. So I could have rewritten that as 6 plus y equals 10, and then 6 plus 2y, because y plus y, 1y plus 1y is 2y. And then I can subtract 6 from both sides, so 2y equals 4. And if 2y equals 4, y must equal 2. So up here, now this was y that I solved for first, so I'm still looking for x. So now that I have my y, I go into my first equation and I say x minus equals 6, and in for y, I'm going to substitute 2, and so I get x minus 2 equals 6, and when I add 2 to both sides, I get x equals 8. So I think my x is 8, but I can always check. Does 8 plus 2 equal 10? Yes, it does. Does 8 minus 2 equal 6? Yes, it does. So I know I am right. Okay. Last one, then we're going to do some story problems. So here we go. Y equals 3x plus 1. Y is alone, so I take this y and I plug it in there. So I'm going to do 6x minus 2 times y equals negative 2. But instead of y, I'm going to put what y equals, 3x plus 1. So 6x minus, I'm going to distribute, 6x minus 2 equals negative 2. And 6x minus 6x cancels. So now I'm left with negative 2 equals negative 2. Notice that all my variables went away. No more variables. When that happens, I know it's either a no solution or an infinite number of solutions. And how I tell the difference is that I look at the resulting equation and I ask myself, is this true or false? Is negative 2 equal to negative 2? It's true. If it's true, that means it's the exact same line. So I have an infinite number of solutions. And that would be my answer, infinite. And if it was false, then I would know it was a no solution. That's how you tell there. Okay, let's zoom out so we can do this story problem. Okay, so as part of her weekend job, Aisha went to the snack hut to pick up snacks and drinks for her fellow workers. She purchased a total of 19 items and paid $64.25. How many snacks and how many juices did she get? So what's really important when you solve systems is to understand that there's going to be two different equations representing two different things. Our first equation is going to represent the items. That's our first equation. And our second equation is going to represent the money, how much she paid. And we're not going to mix those two. So we're going to have to set up what we want to call snacks and juices. So I'm going to call snacks, I'm going to call them K. So this is going to be the number of snacks. That's going to be K. The number of juices, I'm going to call J. So I know that I don't know how many snacks and how many juices, but I know that if I took the number of snacks she bought plus the number of juices she bought, what would I get? Well, it says there were 19 items. So if I took the number of snacks plus the number of juices, I know I'm going to get 19. So that's my first equation. Now notice there's no money involved there. It's just talking about how many. So I have a how many equation. Now I'm going to have a how much money equation. So that's my how many equation. Now my how much equation, how do you find out how much she paid for snacks? Well, each snack was $4.75. So I know that if she had 1 snack, which is $4.75, if she had 2, then I would times it by 2, and 3, times it by 3. I'd times it by however many she got. Since I know she got K snacks, then I know that if it was 3, I would multiply by 3. If it was 5, I would multiply 5, etc. So I know that this represents how much money she spent on snacks. So how much money she spent on juice would be represented by 1.5J. And if I take the amount of money she spent on snacks and I add it to the amount of money she spent on juice, I know that I get $64.25, which is the total she spent. Now I have 2 equations. Now I can use substitution to solve and figure out how many she bought. So obviously this one is the easiest to get J or K alone. So I'm going to get K alone. I'm going to subtract a J from both sides, and I'm going to get this. And then I'm going to take this and I'm going to substitute it in for K, because it says K equals. So I'm going to rewrite this 4.75 times 19 minus J plus 1.5J equals 64.25. And now you'll probably want your calculator, because I don't know what 19 times 475 is, but I'm going to find out. 475 times 19. $90. That's a problem. That's a really big problem. Why is that a problem? Because she couldn't have spent $90 on. Oh, okay. That's not a problem. We're just going to go for it, because hopefully it'll work out at the end. I'm thinking she couldn't have spent $90, but it's not she didn't buy 19 snacks, right? She bought 19 minus J, so it just messed me up for just a minute. We're going to distribute. It'll work out. So we just distribute there, and here we go. We're going to just put that down. 64.25. So now I'm going to combine like terms, and I lost a variable somewhere. Sorry about that. That was a variable. That was J. I'm going to combine these two. So what's 475 plus 150? Well, 475 plus 150, we're going to get 625. J, here's our total over here. We know she spent, and we have 90.25. And something is wrong somewhere. Okay, I see my mistake again. I made several mistakes. Sorry, that threw me for a minute. That's a minus sign because it was times negative J. So that means this is going to be different. So it's going to be 475 minus 150, which will be 325. Isn't it fun to make mistakes? It's only good if you can find them. Okay, I knew that was wrong because I knew I was going to get a negative here and I wasn't going to get a negative there. That was my tell. Okay, I'm going to subtract 90.25 from both sides. One of the hardest things I've had to learn is how to find my mistakes. It is not easy to do, but it is very beneficial. So this is negative 26, and I'm going to get negative 325. J, so now I have to divide by negative 325. So what is 26 divided by negative 3? Did I say 25? 25. Yes, that's a 2. So 8. Well, what did J represent? J represented our juice. And now it's super easy because we don't want to substitute back in this one. We want to substitute it in this one. Because we know that if she bought 8 juices and she bought 19 items, that she got 11 snacks. Right? So, and we can just double check. This is how you double check. You know, 11 times how much a snack costs, right? Because it's 11 of those. Plus, we've got 8 juices, and those were $1.50. And did it equal 64.25? Yes, it did, so we know we're right. So a lot of times you need to write a sentence to a word problem. So you'd say, I'm not going to write it, I'll just tell it. She bought 8 juices and 11 snacks. Because this doesn't really tell you that, unless you go back up. Okay, last one. A lawn mower costs $200. The gasoline per lawn is $2. So it says Nate is starting a lawn mowing business, and in his business he has an expense and revenue. We're going to have 2 equations, one for expenses, one for revenue. So that's how much he spends, how much he makes. Nate's expenses are the cost of the lawnmower and the gas, and his revenue is $25 per lawn. So our revenue equation is how much he makes. He makes $25 per lawn. So we're just going to call lawn number of lawns X, number of lawns, right? So if he mowed 2 yards, he's got $50 in his pocket, right? He still hasn't paid for his lawnmower, but he's got $50. If he's 10 lawns, that's $250. So This is the number of lawns. Well, what would y be? Y would be the money, right? The money that he made. So on our expense account, well, he had to buy, right? This is how much money he spent. He had to buy a $200 lawnmower, and every time he mows a lawn, he has to pay $2 for gas. So this, although it still represents money, right? This represents how much he's spent. This represents how much he's made. Now, there's a lot of businesses do this. When they start up, they have to spend a lot to get it started. It's a while before they make money. So when the expenses equal the revenues, that's my break-even point. After that, I start making money. So we have these two equations, our expenses and our revenues, and if we set them equal to each other using substitution, then we find how many lawns it would take in order for him to start making money, to pay off all his lawnmower. So since they both equal y, we just set them equal to each other. It's kind of we take this 25x and we plug it in for that y. So we're going to subtract 2x from both sides. We're going to get 200 equals 23x. And I need an equals there. And so we are going to see how that works out. It's 200 divided by 23, and we get 8.6. Well, do you think he's ever, it's really 8.7. Do you think he's ever going to mow 8.7 lawns and then just stop three-quarters way through the lawn? No. So what we would say was, how many lawns would he have to mow in order to break even? He'd have to mow 9 lawns. So we'd say 9 lawns. At what point will Nate's revenue exceed his expenses? When he mows 9 lawns. He will then be actually making money. Okay, good luck with that. Remember our steps. You got to solve for one of the variables and substitute it back in. M squared, signing